Hi guys, I am Santosh Babbanrao Gaikwad, working as a Assistant Professor, Department of Chemistry, Let Pundlikrao Gavadi Arts and Science College, Shirpur Jain, District, Washim. In previous lecture, we study about organometallic chemistry. In this topic, we specially focus on one of the most important organometallic compound, that is organomagnesium compound. In this lecture, we are studying another most important organometallic compound, that is organolithium compound. In this topic, we study about its synthesis and its reactions with different reagents. Before we start in deep, we have to know about what is organolithium compound is and its reactivity. An organolithium reagent is an organometallic compound with the direct bond between carbon and lithium metal. With the formation of carbon to metal bond, it effectively creates a carbanion. Due to the electropositive nature of lithium atom, moves most of the charge density of the bond on the carbon atom. This is also a good reducing agent. Organolithium compounds are extremely powerful bases and nucleophiles. Here we can see general formula of organolithium compound, that is RLI, where R is any substituted alkyl or aryl group and Li is a lithium metal which is directly attached to the substituted alkyl or aryl group. There are a wide range of compounds which are commercially used in organic synthesis. We can see few examples of organolithium compounds here. First example is phenyllithium or lithobenzene, which is an organometallic reagent. It is the most commonly used as a metalliting agent in the organic synthesis and substitute for the Grignard reagents for introducing phenyl groups in organic synthesis. The next example is methyl lithium. It is the most important and highly reactive organometallic compound which we can use as a base as well as nucleophile in organic synthesis. The next example is butyl lithium. In short, we can say N-Bully is an organolithium reagent. It is widely used as a polymerization initiator in production of elastomers, and also it is widely employed as a strong base or super base in the synthesis of organo compound as in the pharmaceutical industries. The next is lithium tetramethyl piperidine, often abbreviated as LiTMP or LTEMP, is a organometallic compound. It is used as a non-nucleophilic base. The next is LDA, that is lithium diisopropyl amide, which is a strong organic base. This can be used as a drive the ketone enolate equilibrium completely to the enolate side. The steric bulk of its isopropyl groups makes LDA non-nucleophilic. The next example is tertiary butyl lithium. It has application in organic synthesis since it is a strong base capable of deprotonating many carbon acids including benzene. Now we move on some historical background of organolithium compounds. Wilhelm Johannes Schlenk was a German chemist, which we can see above my head, who discovered the organolithium reagent, that is RLI, in around 1970. But only since the 1950s, based on the pioneering work of George Wittig and Henry Gilman, organometallic reagents become a routinely used tool in organic synthesis. The use of organolithium compounds can be classified in the major application like strong bases, nucleophiles, metal exchange, and reducing agent etc. Now we study synthesis of organolithium compounds. In this synthesis, we take a general reaction. When alkyl halide reacts with metallic lithium in presence of diethyl ether or tetrahydrofuran or N-hexane at 263 Kelvin temperature. This gives alkyl lithium product, which we can see here. In specific example, methyl lithium can be synthesized by reaction of methyl bromide with metallic lithium in diethyl ether in an inert atmosphere of nitrogen or helium at 263 Kelvin. Here we can see this reaction. We synthesized organolithium compound, but we have to know about its properties. In this topic, we covered its physical appearance, stability, reactivity, polarity, as well as its ionic characters. Organolithium compounds are colorless liquids or low melting solids. They react with compounds which can supply H+ ions. These are insoluble in water but soluble in organic solvents. These are strongly polar covalents. They are particularly sensitive towards air and moisture. More electropositive nature, more is the ionic character of organolithium compounds. Organolithium compounds are more ionic character than the organomagnesium compounds. That is, ionic character of bond between carbon and lithium is approximately 35%, whereas the bond between carbon and lithium is 43%. Hence, ionic character of alkyl lithium is greater than Grignard reagent. Due to this, we can say that the organolithium compounds are more reactive than organomagnesium compound, that is Grignard reagents. Now we come to our most important part of the lecture, that is the reaction of organolithium compounds. Now we start with the first reaction, that is synthesis of alkane. When methyl lithium reacts with water molecule, which gives alkane takes place, which we can see in this reaction. In possible reaction mechanism, methyl lithium reacts with water molecule. In first step, negatively charged methyl group in the organolithium compound attacks on hydrogen in water molecule, which releases of hydroxyl molecule, which further attack on positively charged lithium metal, forms lithium hydroxide as a side product with the major product alkane, that is methane, which we can see here. Now we move on our next reaction, that is reaction with formaldehyde. In this reaction, alkyl lithium, here methyl lithium, reacts with formaldehyde in diethyl ether. This reaction gives primary alcohol, that is ethanol is a major product with the loss of lithium hydroxide. In possible reaction mechanism, the nucleophilic carbon of methyl lithium reagent adds to the electrophilic carbon in formaldehyde. Electrons from the carbonyl carbon moves towards the electronegative oxygen, creating an intermediate lithium methoxide complex by the attack of positively charged lithium ion. The lithium methoxide complex on acid hydrolysis with dilute sulfuric acid or dilute hydrochloric acid on protonation of alkoxide oxygen creates an primary alcohol, that is ethanol, with the loss of lithium hydroxide, which we can see here. The next reaction is reaction of methyl lithium with acetaldehyde or aldehyde other than formaldehyde. In this reaction, acetaldehyde reacts with methyl lithium reagent, which gives intermediate complex. This complex on acid or base hydrolysis gives our product secondary alcohol, that is isopropanol, which with the loss of lithium hydroxide. In the possible reaction mechanism, we can say that the nucleophilic carbon in methyl lithium attacks on electrophilic carbon of carbonyl group. Simultaneously, electron from the carbonyl carbon moves on the electronegative oxygen, forms an intermediate lithium isopropoxide complex by the attack on positively charged lithium ion. In the second step, formed complex on acid hydrolysis with the dilute sulfuric acid or hydrochloric acid on protonation of alkoxide oxygen gives secondary alcohol, that is isopropanol, with the loss of lithium hydroxide we can see here. In next reaction, we are studying reaction of organolithium compound with ketones. In this reaction, when methyl lithium reacts with acetone in diethyl ether, firstly it forms intermediate product, that is lithium tertiary butoxide by the attack of positively charged lithium ion. Next, on acid or base hydrolysis gives tertiary butanol. In the possible reaction mechanism, we can see when nucleophilic carbon of methyl lithium attacks on carbonyl carbon of acetone, this forms intermediate compound. In next step, prepared complex molecule on hydrolysis with dilute mineral acid gives product. In this step, complex ion attacks on proton, that is positive H positive. In this step, complex ion attacks on proton, that is H plus ion, and with the loss of lithium hydroxide forms tertiary butanol. We have studied most important three reactions. From these previous three reactions, we can say that when organolithium reagent reacts with formaldehyde gives primary alcohol. Next, when organolithium reagent reacts with acetaldehyde or aldehyde other than formaldehyde gives secondary alcohol. And similarly, when organolithium reagent reacts with ketone, it gives tertiary alcohol as a major product. Now we move on towards next reaction with ethylene oxide or epoxide. In this reaction, ring stain makes epoxide or ethyl oxide more reactive than ether. When methyl lithium reacts with epoxide in diethyl ether, this reaction breaks the three-membered cyclic ring of epoxide and form addition product, which on hydrolysis gives primary alcohol, that is N-propanol. In possible reaction mechanism, nucleophilic carbon of methyl lithium attacks on one of the electron deficient carbon in the epoxide ring. Due to this nucleophilic attack, three-membered cyclic system opens and formation of propoxide ion takes place, which combines with positively charged lithium ion. Prepared addition product on acid hydrolysis in dilute hydrochloric acid gives primary alcohol as a primary alcohol, that is N-propanol, we can see here. Now we take reaction of ester with organolithium compound, that is reaction of ethyl acetate with methyl lithium. In this reaction, ethyl acetate reacts with methyl lithium reagent. It forms tetrahedral intermediate complex. With the loss of ethoxylithium molecule, formation of acetone takes place. This acetone further reacts with another molecule of methyl lithium after acid or base hydrolysis gives tertiary butanol. We can see here. Now we take overlook on reaction mechanism of this reaction. In this mechanism, nucleophilic carbon of methyl lithium reacts with or add to the electrophilic carbonyl carbon of ethyl acetate in presence of diethyl ether as a solvent. Initially, we get tetrahedral intermediate addition product, which on loss of ethoxylithium forms ketone, that is acetone, which we can see here. Our required reaction is completed with the single molecule of methyl lithium with ester, whose product is acetone, but we can continue this reaction with addition of another molecule of methyl lithium in it. Now we add another molecule of methyl lithium with acetone. Nucleophilic carbon of methyl lithium attacks on electron deficient carbon of acetone. It forms tetrahedral intermediate of tertiary lithium butoxide molecule, which on acid hydrolysis gives tertiary butanol as a major product with lithium hydroxide, we can see here. Now we study next reaction, methyl lithium with carbon dioxide. When carbon dioxide reacts with methyl lithium in diethyl ether, it gives intermediate complex ion, which on acid hydrolysis in presence of dilute hydrochloric acid or dilute sulfuric acid, which gives acetic acid. If we use another molecule of methyl lithium in diethyl ether followed by acid hydrolysis, we get our final product, tertiary alcohol. Now we study reaction mechanism of this reaction stepwise here. Reaction mechanism start with the attack of nucleophilic carbon of methyl lithium on electron deficient carbon of carbon dioxide, which opens double bond between carbon and oxygen with formation of new bond between methyl group of methyl lithium and carbonyl carbon of carbon dioxide and formation of intermediate ion. This intermediate on acid hydrolysis forms acetic acid as our required product, which we can see here. Here, when another molecule of methyl lithium in which nucleophilic carbon of methyl lithium adds on electrophilic carbon of acetic acid, it forms tetrahedral intermediate. With this tetrahedral intermediate ion, another methyl lithium molecule reacts as a base and abstract proton from hydroxyl group and forms dianion compound with lithium ion. This dianion on hydrolysis with dilute mineral acid first forms geminantiol, which further converts into acetone, which we can see here. We also continue this reaction with acetone with methyl lithium in diethyl ether followed by acid hydrolysis gives tertiary butanol, which we can see here. In this total reaction mechanism, we used 4 molecules of organolithium reagents. In this reaction, we observed both the properties of organolithium reagent, that is its basic as well as nucleophilic property of in this same reaction. If we compare reactivity of organolithium reagent with organomagnesium compound, we observed in previous lecture that when Grignard reagent reacts with acetic acid, it does not give addition product. But when organolithium reacts with the acetic acid, it gives or it goes to addition product due to the higher reactivity of organolithium compound over the organomagnesium compound, which we can see here. Now we study next reaction of acetyl chloride with organolithium reagent. In this reaction, acetyl chloride reacts with methyl lithium in diethyl ether. It gives tetrahedral intermediate ion, which on acid hydrolysis with dilute mineral acid gives ketone, that is acetone, which we can see here. Another molecule of methyl lithium reacts with acetone in diethyl ether followed by acid hydrolysis gives tertiary butanol, which we can see in this reaction. Here we are studying mechanism of this reaction stepwise. Reaction mechanism start with nucleophilic carbon of methyl lithium attacks on electron deficient carbon of acetyl chloride with the opening of double bond between carbonyl carbon and oxygen attached to it. The formation of tetrahedral intermediate takes place with lithium ion. On acid hydrolysis with loss of lithium hydroxide, formation of acetone takes place. We can also continue this reaction of acetone with methyl lithium in diethyl ether followed by acid hydrolysis gives tertiary butanol, we can see here. In this total reaction mechanism, we use 2 molecules of organolithium reagents. Now we study last reaction of organometallic reaction. In this reaction, methyl cyanide reacts with methyl lithium in diethyl ether as a solvent. Initially, it forms addition intermediate on acid hydrolysis, which on acid hydrolysis with dilute hydrochloric acid gives ketamine. Further hydrolysis of ketamine with dilute mineral acid, which gives acetone. Another molecule of methyl lithium reacts with acetone in diethyl ether, followed by acid hydrolysis gives tertiary butanol, which we can see in this reaction. Now we study reaction mechanism of this reaction stepwise. In this mechanism, the nucleophilic carbon of methyl lithium reacts or add to the electrophilic carbon of polar nitrile group. Electrons from the cyanide moves to the electronegative nitrogen, creating an intermediate imine salt complex. On an acid hydrolysis, the addition of aqueous acid, that is addition of dilute mineral acid, the intermediate salt protonates, giving the imine, which we can see here. An acid hydrolysis reaction continues and imine undergoes nucleophilic addition, but it requires activation by protonation, that is acid catalysis. Now the nucleophilic oxygen atom of water molecule attacks the electrophilic carbon atom with the pi bond, breaking the neutralize the change on nitrogen atom. An acid hydrolysis reaction continues. It deprotonates the oxygen from the water molecule to neutralize the positive charge. In the next step, before the nitrogen system leaves, it needs to mate into a better leaving group by protonation. The use of electron on the oxygen in order to push out nitrogen leaving group, a neutral molecule of ammonia. Deprotonation reverses the formation of acetone takes place. Another molecule of methyl lithium reacts with acetone in diethyl ether, followed by acid hydrolysis gives tertiary butanol, which we can see in this reaction. With this, we conclude our today's lecture here. I think all of you satisfied with this knowledge. If any query about content, comment me in comment box. If you like this video, please press like button and don't forget to subscribe here. Also click on bell icon for notification of my new video. Thank you very much for watching this video.